Hello, everyone. Welcome to the mentee presentation for the Open Mainframe Project Mentorship Program. This is our 5th year of doing this program. We've seen some really great work over these last 5 years. Personally, this has been one of the most enjoyable parts of not only Open Mainframe Project, but just participating in open source overall in my career to be a part of. And you know, we're in no shortage here today. We have some great young minds here that are excited not only about open source, but the mainframe as well, and have made some great contributions to projects that are within that space and looking to support that space. So I want to introduce this group of folks today, and you'll get to learn a little bit more about them, the project, their thoughts on the mentorship, and I would encourage all of you to look to connect with them afterwards. These are some great students. They're excited about the space, and they definitely are looking for great opportunities to continue their journey. So with no further ado, let's turn it over to the first mentee.
So I hope you all can hear me. Hello?
Hi, yes.
Yep, we can hear you loud and clear. You're good.
Great. So hi all. I'm very happy to present on what I was working with the Zowe team on last summer. And so I'm Ayushmanta Pereira, working as a software engineer in Salzburg Research now in Austria. I was studying in Sri Lanka Institute of Information Technology, and I'm interested in full stack development, including DevOps practices as well. Also, I'm an open source enthusiast. You can find me in a couple of other organizations as well, as a committer in OpenMRS and Apache Software Foundation. Also, you can contact me with the Twitter handle mentioned in the slide here. So that's a lot about me. So I would like to move on to the presentation. So I'm not going to talk a lot about Zowe here, as we are in the Mainframe Mini Summit, but I would like to highlight the mission of Zowe. Zowe has a mission focused on providing simple, open, and familiar tooling platform for COA system programmers and developers. I wanted to highlight this since the file trans application development project is all also about providing functionality to help COS programmers and users. And next, I thought about giving a brief idea about the Zowe Big Picture. We have Zowe application framework, which provide the virtual desktop, and we have API mediation layer and Zowe CLI. So the file trans application that I was worked on during the summer resides inside the Zowe application framework as a plugin developed for Zowe virtual desktop. So now we have an idea about Zowe. So let's have a look at the project. So the main requirement of developing a file trans application is providing an application which make it easy for COS users to transfer larger files and data sets from mainframe and to mainframe from users desktop, vice versa, in an easy, secured, and scalable manner. So when I was applying to the project, this idea impressed me because it seems to be a great addition to Zowe and mainframe, because lots of COS users who are working with mainframe work with larger files and data sets in their day-to-day life. Apart from the development of file transfer application, I'll use FTA because it seems short and sweet. So I work with CSS team who are working on exposing the functionality of COS as C-level APIs in order to fill up the missing functionality of Unix files and datasets which are required for the FTA. To give a small idea about how the Zowe components are interacting with each other, where the FT will stand on the ecosystem, let's have a look at the below architectural diagram. So we have Zowe Virtual Desktop, and we have FT installed there as a plugin. There it will be directly interacting with the Zowe app server, which underneath handles the communication between the plugin and the CSS server. CSS server is the API layer which exposes the functionality of COS as C-level APIs. So this is an overview of how components are working with each other in Zowe. So since we don't have much time, I'm not going to do a demo here, but with the below diagram, I'll walk you through it, what we have done so far. So as you can see, it has a file explorer, which is a great tool developed by Zowe team. This has the capability to visualize the USS and MBS file systems on the mainframe via a file and folder hierarchy as a tree. Functionalities like cut files, copy files, move files, delete files in mainframe, and many more provided with the Explorer. I got the opportunity to work with the team to improve some functionality on file tree as well. So a file tree, or we can call it Explorer, is a very important feature for FTA as well, because in FTA we care all about files and data sets, and the first thing we did was to integrate the File Explorer into FTA. And when we have the File Explorer in place in the FTA, as you can see, we have lots of metadata related to a file, like the ownership of the file, the size of the file's actual path in the mainframe. This made things very easy for me to continue development. Next, we wanted the solution where we can download large files in browser without consuming lots of memory of end users machine. We tried out different libraries, and finally we went with streamsaver.js. So it has around 10,000 weekly downloads. So it seems to be doing a great job for us for our project. So, and it was very stable, and it was there for a couple of years. So we thought of moving forward with streamsaver.js. So streamsaver.js takes different approach. Instead of saving data in client-side storage or in memory, it creates writable stream directly into the file system. So I'm not talking about the Chrome sandbox file system or any other web storage. It directly interacts with your file system. Still, when we are testing things in different browsers after integrating streamsaver.js up to FTA, readable streams are there in all browsers, but not writable streams are there. So the download kit fails sometimes. To overcome this, we use WebStream polyfills, and that's how we came up with a solution for large file downloads. So after a single file download, we thought of giving support to download folder content. And in the file transfer application, we have defined a separate UI workflow which will inform user regarding folder download and download content as tar file. This was done in tar compression since it requires less compute power than creating a zip folder in mainframe. Compute power is always a critical factor to think, since there are a lot of ongoing tasks in mainframe in a given time. So we went with tar compression. And then we thought about adding more functionality to FTA, which will help users, which are very obvious to have in an application like this. So we added support to queue downloads and the priority of downloads. Also we maintain 3 states in the app: in progress, cancel, and completed downloads, which will give a clear separation to the user during a download activity. The application handles these state changes in a real time after download happens, and also gives user notification on activity status as well, which seems to be a very user-friendly way of handling things. And also for later usage, we maintain a list of previous canceled and completed downloads in the user scope for a particular user. As well, these are displayed in the data tables, so user can easily filter out previous activities as well. When moving forward, we thought of giving the user the ability to define the number of downloads, number of history of items that they can maintain in the FTA. We have defined a separate UI workflow for that. As you can see in the FTA, we have separate workflow to maintain the user configs. In the meantime, users have the ability to see the history of search they have performed in their previous logins and in their previous interaction with the FTA application as well. And for end users, I have to highlight that all in-progress downloads will be canceled and move into the cancel section if you close the application during download. Finally, files in mainframe are stored either in EBCDIC, ASCII2, or UTF-8 encoding. When downloading files, it's easier to download UTF-8 files. It will be automatically converted, but EBCDIC and ASCII2, we have to define what is the source and target encoding types of files should be in order to download to work. In file transfer application, we have addressed that in a UI with a very easy and user-friendly way as well. So we have achieved a lot in FTA, and there are some features in progress as well, like dataset downloads currently that we are working with the team. And I hope you enjoyed my presentation. To have a look at the full presentation and all the work and demo, you can follow this YouTube link, and all the work related to the project and the PR are stored in Open Mainframe Project Internship repository as well. And that's all about me. From my end, in the file transfer application. I would like to thank all the Zowe team members who worked with me, especially Sean and Lenny. Thank you all. That's all from me.
Awesome. Thank you so much, Ayesh. It was, it's great to see that sort of contribution and a great collaboration with the Zowe community. We can definitely tell your contributions are making a great positive impact there. Let's move on to Ayush Jain. If you want to take over and present your project work.
Yeah, sure. Sorry, I had some trouble setting up.
No worries, no worries, whenever you're ready.
Is my screen visible?
I don't see it visible presently, no.
Yeah. So this is basically the presentation tag for the file and storage module, and I am Ayush Jain, an undergraduate computer science student, and from PS University, Bangalore, India, and I really love open source, and I've explored a lot of open source systems actually. And what got me curious in the Open Mainframe project was the Open Mainframes 6 nines reliability. So I was pretty much interested in knowing the 6 nines, like how mainframe achieve that reliability and efficiency. So that's how I got to know about mainframes. And one of my friends told me about the Open Mainframe project. So then I started exploring the projects, and the FEILONG Ansible project, like I was pretty much curious about the storage systems as well. So this seemed to be quite a fit, and I applied it in it and I got through lucky. So previously I have also interned at About Code at the prestigious Google Summer of Code program. So there I did Japan packaging, and I got to know about Linux systems pretty well. And this time I got a touch of S390X architecture on which basically Linux One systems work. So that's how I got interested in. And my mentor for the project was Vincent Teron, and he works at Vicom Infinity. So that's basically about us. And now I will go take you to the deck and show you the journey from how we build the system from scratch. So basically, we had to build the system for the storage Ansible module for FEILONG guys. FEILONG is a development SDK for managing ZVM in a very simple way. And it's basically a project which is being made to advance the use of ZVM or make it easier to use ZVM. And it can do a whole lot of things, like it can create gas, images, networks, and allocate volume and all those sort of stuff. So our work was to make it easier to allocate block storage to FEILONG. So that's where the initial name FEILONG for the project comes in. And now I'm going to tell you about Ansible. So, and we are creating basically an Ansible module or playbook to integrate the storage, or basically allocate a block of storage to a piece of host, or basically a block storage to a host inside ZVM. So that was our work. And Ansible is basically a configuration management tool or a deployment tool, which makes it easier to work across machines, and it can do 100 machines at a time. So if you want to install some package into 100 machines, you can basically put all those addresses of the machines into an inventory file and run a command. So that command will be run on those hundreds of machines via SSH. So basically for Ansible running, you need Python and SSH. So if you basically all the Linux systems have inbuilt Python in them, all the distros. So that's a fit we got, and that's why we thought of creating, or my mentor thought of creating an Ansible module. So now I'm going to take you through the architecture of the project. Basically, like the inner details, what we call it. So on the leftmost side, you can see a FEILONG block. That's basically a FEILONG SDK that might have a allocate storage or block storage function. So that function will basically do a REST call to our server, which will be a post with a certain details, and in return or response, it will get the block storage. So what we have done is we have created a server in Python using Flask, and inside that server, we pass the request to get the parameters from the body, and using that, uh, we run the Ansible playbooks using Ansible runner. So basically a playbook or a module. So a module is basically doing the work, and playbook is written on top of the module. So what playbooks we have written, these will have a general sense or a general configuration. Like the first step in playbook would be to make a volume and then map it to the host and whatever variables we need. So that will be taken out and returned to the FEILONG project. So what our playbook does is it contacts the storage via REST call or SSH. So it contacts the storage and gets the storage and do all the necessary things like mapping the storage to the host and whatever variables we need from the storage. So those are pulled from the storage, and then then those are passed to the FEILONG project. So basically, as I told you, our playbook can contact the storage. In this case, we were using IBM DS8K or FS8K. You can use any of the storage. Just you need to create a general playbook for that storage, and you need to place the playbook there. Then it works like a magic. So as I told you about uh, our server talking to the storage, there are two ways: SSH and REST API. So IBM DS8K has both the functions enabled. So mostly many of the storage systems do have REST APIs. So it's pretty easy to contact through them. So we have enabled both the modes in our project, SSH and REST API. So you can pretty much use both of them and contact or create storage in any of the storages like uh, Dell EMC and etc. So basically what parameters you need to pass through REST call to create a storage. So in our case, FEILONG needed to create a storage. So we need to pass host ID, size, pool. So basically host ID is the ID of the host, what we are running, and the size of the storage, and the pool is basically from what pool you need to create the storage. And you need to pass those in a form of JSON, and you will get a reply in JSON with the parameters of SCSI learn ID, which is the storage block attached to the host ID, host basically, and WWPN, which is the unique worldwide port number of the storage to map it back to the host. So that's basically the inputs and outputs we pass into the server. And how does server basically does that? So as we have seen, like server has a playbook which will create a create a volume, then map the volume back to the host and pull out the variables what we need. So this is all done in our server using Ansible runner package. This is basically a package equivalent to uh, AWX. So AWX, Ansible AWX is a commercial component to basically handle REST APIs. So Ansible runner is basically the open source part of it, or or the core part of it. So using that Ansible runner, we are running the playbooks, and basically our playbooks execute on the storage, gets our work done, and we pass. So Ansible gives a lots of output. So we need to pass the output to debug what variables we need basically. So we need WWPN and SCSI and ID. So we pass that, and that is sent back to the FEILONG after passing. So basically we need to, and for running the playbook, we need to give the storage address as well. So that's given in the inventory file. So that's basically it. And if any one of you have any queries related to the project, you can ping me or Vinny, my mentor, as well. And the GitHub repo for the project is easily accessible from the Open Mainframe project repository. And here's the link. Yeah, so that's it from my side. John, over to you.
Awesome. Thank you so much, Ayush. It's great seeing Ansible and the FEILONG project come together. I think that's a great value proposition to help connect to ZVM, which is the stalwart virtual machine technology in the Z world, in the mainframe world, back to modern tooling like Ansible. I know that there's a ton of interest in that space here, and it's great to see a project that's kicking this off. And definitely look forward to where this is to go, and hopefully a lot of this work is making itself upstream in FEILONG. So I want to move next to, you're welcome, next to Ayush Sridhar. If you want
yeah,
to,
that's right. Can you hear me?
I can. If you want to present your screen.
Oh, yeah. All right, so is my screen visible?
It is.
Awesome. So just to start us off, my name is Ayush. I was an OMP mentee for 4 months, working with James Caffrey on the ADE project. Over the course of the next few minutes, I'll try to summarize whatever I did, how this particular project fits into the grand scheme of things, and what we plan to do with ADE in the coming future. So just for some reference, like I said, my name is Ayush. I am a recent computer science graduate. You can reach me on LinkedIn with this particular handle. I'm also pretty active on Twitter, and I've been involved with open source software development for pretty much 3 years now, ever since I started my sophomore year. I've previously been a Google Summer of Code student and with focus mostly on machine learning based technologies, which is kind of why my interest was piqued in ADE, because I found this entire concept of using data science for anomaly prediction to be pretty cool. So I'll just start off with what ADE is. And naturally, the first question that we need to address in order to have a clear picture is, what is ADE? So ADE stands for Anomaly Detection Engine, and the name is pretty self-explanatory. But just to give you some idea, this is a project which is supported by the Open Mainframe Project. It's been an active project for about 3 to 4 years now. And this project uses, the idea behind this is to use statistical learning and unsupervised learning to learn useful trends from large or huge amounts of log data, and then use this acquired information during inference time to predict if some kind of log might cause anomalous behavior in our system. So that's kind of what ADE does. At the moment, ADE supports 2 formats of Linux syslogs, RFC 3164 and RFC 5424. My project was to expand support from just syslogs to more complex middleware logs, such as Spark in this case. So Spark logs are comparatively way tougher to deal with, and that's mostly because they are way dense and way dirty, because they don't have a common pattern, and that kind of makes this problem really difficult. But the first question that we should ask ourselves is, the next question we should ask ourselves is, why exactly do we need ADE, right? So these are just some of the news excerpts taken out from leading media sources that are highlighting why software failures have been a major pain in the industry. These particular failures are really hard to deal with, mostly because most of them are at a very great scale, and they cause massive delays in terms of time, loss of resources such as money, and most importantly, loss of data. And the worst part is that debugging these things is a hard job, and these crashes are bound to happen. As we develop more and more advanced software that runs on thousands of systems and serves millions of clients, we are going to see more and more problems in terms of scalability, in terms of small bugs that pop up in our system that might cause these systems to crash at some point. And it's like they say, the only bug-free software was the software that was never written. So we try to focus our attention on the second part of the problem. That is, if we can't stop the problem, why don't we look at solutions to efficiently deal with the problem? And that's kind of where data science comes in. So data science, as a very broad topic, is kind of at the conjunction of computer science and mathematics. The broad idea behind data science is to use data, is to implement algorithms that learn from prevalent data and apply these learned information to data we've never seen before in order to predict usable and valuable results. That's also kind of what ADE does. So at the moment, what ADE does is that it learns various trends from data that we have already seen before, which is like log, really huge amounts of text data. And then and then once ADE is already running, it can actually predict an anomaly score. So it comes up with a model, with a mathematical model that then helps us come up with an anomaly score that kind of assigns a number to every log slice that we see. And so the higher the anomaly score, the greater are the chances of this particular log slice being responsible for causing anomalous behavior. So the objectives of this project were broadly to add support for Spark within ADE. ADE had not really been active for about 2 years now, and we decided that a good point to make this project active again would be to introduce Spark within this, since that kind of increases the usability from just this log-based perspective to more middleware and web server or high-performance computing-based applications. Although this goal looks simple enough, there are a number of steps involved. Most importantly, at a very low level, we need to develop a process that read these Spark logs, implement some kind of regex matching to extract information from these Spark logs, add masking in order to make sure that we do not include sensitive information, integrate everything with the prevalence system, which was developed before this. And then at a very high level, integrating these with command line arguments that can be easily toggled in order to switch between Spark logs or Linux syslogs. And then once most of these things are done, we need to set up the data, train our model groups, and analyze. These analysis results are then written out as XML templates, which can easily be viewed in a web browser to get an idea of what might be going on under the hood. So an example of analysis is this. So this particular screenshot is kind of what the analysis result looks like for 10 minutes of analysis. So as you can see, we have various message IDs, and we have assigned a number of scores to this ID. Each of these scores gets combined to give it a total interval anomaly score, which is on the top right of this particular image. And mind that this is just for 10 minutes. So this thing essentially runs for 6 into 24 into this 6 into 24 times per day. And this number can change on the basis of how dense we want the Spark logs to be. So these 4 months have been a great learning curve for me. Personally, I'll have to say that of all the things I learned, it's really hard to summarize them in just 4 points. But just to put them in one way, first of all, I personally think that designing and experimenting is a way tougher job than implementing. Implementing is kind of like we start off with one point and then usually pivot with another direction. Getting this intuition behind the way to proceed is really tough. And I really didn't think about this much earlier, but I would definitely say that this has been a very big plus point. Secondly, obviously dealing with huge amounts of unstructured data is a hard job because one, it's huge, and second, it's unstructured. Third, communication is vital. That's pretty self-explanatory. And fourth, Java is pretty cool. I never thought I'd say this. I've not really been a big fan of Java, but I really enjoyed working with a huge code base written completely in Java in this case. So just to wrap this up, I would like to thank a few people for whatever they've been doing, starting with James Caffrey. He's been my mentor for this project. I would like to thank him for taking out time from his really busy schedule and agreeing to mentor this project. I found his ideas pretty insightful, and he helped me often when I face certain dilemmas. John Mettick and Robert Darburg for running this entire program, for conducting frequent calls in order to get us onboarded with whatever we need to face next. The Linux Foundation for supporting, and the Open Mainframe Project for supporting ADE. I'm really looking forward to seeing more people use ADE and this particular direction of having ADE for Spark logs in the coming future. Also, I'd like to thank LogHub. So LogHub is a large project that was started by a lab at the Chinese University of Hong Kong. So they have a collection of really large data sets that they publicly provide. So I'd like to thank them for providing me with a bunch of production environment-based Spark logs that I was able to use for testing and analysis bit of the project. I've also mentioned their reference downstairs and if anyone wants to take a look. Also, I'd love to have more people look at this project, use it for their use case, and get back to us, either me or James Caffrey, with suggestions or even just general ideas on this project. It's all available, hosted online, available on the Open Mainframe Project GitHub. Yep, that's about it from my side. Over to you, John.
Oops, he was over there. Awesome. It's great to see contributions to the project. That is it is actually the first project that was in the Open Mainframe Project. It was a code donation from IBM, and it's great to see that project continue to evolve, and we're excited by these contributions to see it go. So we have 4 mentees, I believe, left from what I can tell here, and we're getting close on time here, so we're going to try to move through these as quickly as possible. We might actually have 5. I think next up is Dan. And again, Dan, just try to make sure we keep it under the 4 minutes just so we can have time for everyone. Oh, Dan, can you hear us?
Yeah, I can hear you. Can you see my screen now?
Yep, I can see it.
So it shows the presentation here, right?
Correct.
Okay. Hi everyone, my name is Dan Pawelczynkiewicz. I am an Open Mainframe Project mentee and student at the University of Northampton. This is my 2nd year at the Open Mainframe Project Mentorship. And my mentor is Vlad Ivanov, which is a lead architect at SUSE. I would like to begin with the reasons why porting kubectl to Z is a good idea in the first place. So kubectl, Kubernetes is the orchestrator, is the best orchestrator for your workloads, and together with Cloud Foundry, which is the best friend of any developer, we can bring these two and the simplicity of both to clusters on Kubernetes everywhere. So we want to use kubectl because less developers focus more on their apps and the logic behind it, and less on the underlying infrastructure. As we know, as for Z, as we know, is the system run on the mainframes, and it's a very good system for RAS applications. It's very performant, it's fault tolerant, high security, and so on. So bringing these two together is a no-brainer. It really does make a lot of sense. On next thing. So what have we actually done?
we have built Docker images for Z, so Z compatible Docker images to run the kubectl. So there are two categories. The ones based on Bosch. Bosch is is used to deploy software packed in releases. Then images for Irene, which is the new Kube native scheduler for Cloud Foundry. Next, we've built a Docker image for MySQL, built from scratch because we couldn't find an image elsewhere for Z. And a bunch of packages and OS images built on OpenSUSE build service. We can find all of these images on the Quirks with Z repo on Docker Hub. So next, how have we built the Docker images? To build all Docker images and to make kubectl successfully deploy on Z, we first had to have to build a system and some tooling. So we used Jenkins as a build server and created jobs for all the images. First, we used a script that we made last year on the Open Mainframe Project Mentorship, which can take any Bosch release, test it, and then changes the packages accordingly to the errors we get. Next, once the errors are fixed and the package successfully builds on Z, we use FEILONG for Z, which we have also built last year to create the Docker images. After that, we push it to the Docker Hub Quirks repository. So next, onto testing. This is how we make sure all the applications are working as expected on Z. So first, we deployed kubectl using Helm and start debugging. We used K9S, which is an awesome tool which helped us a lot debugging all the things related to Kubernetes. So you can have logs, you can describe a pod, you can do anything, and it has a nice interface. Following that, we fixed the errors and build all the images again with the workflow described earlier with Jenkins. And finally, we update all the settings. By settings, I mean Docker images, names, versions, and stuff like that, because we built them again and those might change. So that's it for me. I want to thank everybody at the Open Mainframe Project and Linux Foundation, and especially my mentor, which was very, very helpful, and from which I learned a lot. You can find us on Slack, on the crowdfunding Slack, on the CF Dev channel. You can, if you want to learn more about kubectl or contribute to the project, you can visit the repository on GitHub. And if you want to see my work and all the files from this project on the Open Mainframe project, you can visit the GitHub repository on the screen. Thank you. Forward to you, John.
Awesome, thank you, Dan. Great project, and great to see contributions to Cloud Foundry to help support the mainframe even more. Moving ahead here, we have Matish Goplani. Matish, if you want to jump in here, then we have 2 more presentations after Matish. Oh, Matish, are you able to present? I think you're having some audio problems. We can barely hear you. It's getting better.
Hello.
Ah, there we go. There's a little bit of static, but.
Hello.
Can
you hear me now?
I can. There's a little bit of background sound, but it seems to be okay at the moment.
Is it fine? Hello.
Yeah, I think this works. Can you hear us?
Yeah. Hello.
Awesome. Go ahead and do your presentation.
All right. Hello everyone, this is Mitesh Goplani, and today I'm going to present about my work which I did as a part of OMP mentorship on Zowe desktop application state persistence mechanism. A brief background about myself. So I'm currently working as a software engineer at JP Morgan Chase, and I'm also very interested in computer security. I have been certified as an OSCP, OSC, and OSW. These are some cool certifications from offensive security. And I pursued my computer science from Mumbai University. And I was also a principal developer and maintainer of an app called Med Student, which was previously known as Health Savvy app. And I have co-authored a paper titled Animate Object Detection and Queue Ground Control. So why did I choose this project? State persistence mechanism was an interested project provided by Zowe, which required the developer to be well versed with the internal working of Zowe, and also provided an opportunity to contribute to a project that would be consumed by many Zowe apps to persist their states when session expires. So I thought my experience with web development and Angular, along with a bit of a security background, would be really helpful in developing a state persistence mechanism for Zowe desktop, considering the security aspect of the methodology involved. So what was this project all about? As you all know, Zowe has a lot. Zowe is an application framework where a lot of plugins run on top of it. So web plugins running within the application framework did not have access to a secure state persistence mechanism that would allow them to restore their state on the next session login. So the idea was to develop a state persistence mechanism which would allow Zowe applications to be able to save their states at Zowe desktop storage and persist it the next time they try to log in. So this last state of that app gets restored automatically. This is a quick overview of how this system was developed. So we start with these applications. So we had two types of applications on Zowe desktop. The first one was normal desktop applications. The other one were single page applications. So these applications would send the data which they want to save to components such as window manager and simple window manager at regular time intervals. This time interval is configurable according to the requirement of user. So depending on the time interval, these apps would constantly send data to window manager and simple window manager, which would in turn send this data to desktop plugins or desktop storage. So this data is saved separately considering the authentication of the user. So we have two different storages. One is app-based storage, which is for desktop applications. One is single app storage, which is for single page applications. On the next login attempt, authentication manager would try to retrieve those application data on its own from desktop storage and would spawn applications with those data. So consider a scenario where you're working on something really important and you forget to save. So either a browser crashes or you log off or your session expires or something like that. So this mechanism would help you to retrieve back to the last state depending on what was saved on the Zowe desktop. So I got done with this project a bit early in the course of my internship. So I went ahead and took some other projects. So a quick overview of what those projects were. So those are basically focused on improvements on Zelux editor. The first project was tab restore mechanism, where we keep a track of all the open tabs in Zelux editor and restore them on next launch. This is a bit different from what we did in state persistence mechanism, because in this case, we are using editor storage, not desktop storage. So this is specific to Zelux editor, an enhancement to the current working of Zelux editor. We also added copy and cut operations to Zelux File Explorer, which is embedded in Zelux editor. This project, while this project got completed, this would support only USS, but there are plans in future to also support NVS, which are data sets. These are some of links to my work, links to my PR. This is more related to state persistence mechanism, which was my main project. This is for tab restore part, and this is for copy and cut operations. This is a general work which I did. All my work has been documented and saved on this GitHub repository, Zowe desktop application state persistence mechanism. If you go to this documentation folder, you will find a very detailed demo video of the actual working of this system. In notes and research, you'll find an architecture diagram which is a bit more detailed. and the entire link to the source code is there in the SRC repository. If you're interested in this project, please do check this out. And that's it from my side. Thank you so much for listening to me. Over to you, John.
Awesome. Thank you so much. Great presentation there, and great seeing those contributions into the community. So we have 2 presentations left. Zowe, if you want to pop up next, and then we have Kai's here on video.
Okay.
Awesome. Whenever you're ready.
All right. Hello, everyone. My name is Salisu Ali. I am one of the mentees for OMP Mentorship 2020 program. Together with my mentor, Alex Kim, we were able to work on the project Zowe SMF/RMF person engine, which we like to call Zebra. So a little about me. My name is Salisu Ali, like I mentioned. I'm a 4th-year medical student at Bayero University, Kano, Nigeria. I'm a self-taught programmer. I started learning programming in 2016. So I have participated in IBM Master the Mainframe for the year 2017, 2018, and 2019. And luckily for me, in 2017, I emerged as the regional winner for Middle East and Africa. So I like to put my efforts into learning and getting certified in mainframes, IoT, machine learning, Android, and the cloud. I also like building projects on my own, especially when they are related to smart home and telemedicine. So I applied for OMP mentorship to get real-world experience in developing software for the mainframe, and also to build on what I have learned already from Master the Mainframe. So in 2019, the final challenge for Master the Mainframe was on syslog, SYSlog. So when I saw another project related to system logs, I decided to apply for it. That's for the RMF side. So this is a brief description about the project. So Zowe, as we know, is a great system operations tool. So one of the system programmers or performance analyzers' job is to decode SMF/RMF report to check systems health. So if you can create a generic parser for SMF dataset or RMF, this will give these analysts an opportunity to create and reuse many open source monitoring tools out there. This will really make their job easier. So this is the project architecture. As we can see, everything starts with a user's request. When a user sends a request to Zebra, Zebra will now forward the request to RMF DDS server through HTTP API gateway for RMF. Then RMF will now return an XML file. This XML file will now be passed in Zebra. This XML file will now be converted into JSON format. So at this point, the JSON format can be returned to the user through Zowe API catalog or through the browser. And at the same time, we took some time to convert this JSON format into what we call custom Prometheus metrics, which are then stored into Prometheus server. Then from Prometheus servers, users can now connect to Grafana and plot real-time graphs. On the other hand,
Salzi, I don't want to interrupt you. I don't know, you're not sharing your slides if you are talking to slides right now.
Okay, I'm so sorry. I thought I was.
No, no worries, no worries. You were talking great, and we were just trying to follow along, so I apologize.
All right. Also, can you see my screen now?
Yes, we can. And
right,
it's
so
welcome to Grafana. Yep,
yeah,
perfect.
Pardon me, let me get started again. Also, hello everyone. My name is Salisu Ali. I'm one of the mentees for OMP Mentorship Program 2020. Together with my mentor, Alex Kim, we work on the project SMF, Zowe SMF/RMF person engine, which we like to call Zebra. So a little about me. As I mentioned, my name is Salisu Ali. I'm a 4th-year medical student at Bayero University, Kano, Nigeria. I'm a software programmer. I started programming in 2016. I like putting my efforts into learning and getting certified in mainframes, IoT, machine learning, Android, and the cloud. I also like building projects during my spare time, which are related to smart home and telemedicine. I applied for OMP mentorship to get real-world experience. This experience has to do with developing software on mainframes and also to build on the knowledge I have already gotten from Master the Mainframe. So as we all know, Zowe is a great system operations tool, and one of system programmers or performance analyzers' job is to decode this SMF/RMF report to check systems health. So if we can create a generic parser for SMF dataset or RMF, users can now have the opportunity to create/reuse many open source monitoring tools out there. So this is the project architecture. Everything starts with the user's request. Whenever a user sends a request to Zebra, this request is now forwarded to RMF DDS server. The RMF DDS server processes this report and return an XML file. This XML file is then converted to JSON. This JSON data can now be returned to the user through the Zowe API catalog or through the browser. The same JSON data that we have converted from the XML can be stored into Prometheus server, and then from Prometheus server, the user can connect to Grafana. Another use case we made use of is saving this JSON data into MongoDB. So the project use case. The projects have about 5 use cases. We have passing RMF monitor 3 report to JSON. We also have passing RMF monitor 1 report to JSON. We have passing RMF static XML file to JSON. Then we have saving RMF monitor 3 report to MongoDB. And finally, plotting RMF real-time metrics with Grafana. So how can users access data through Zebra? The first option is to use RESTful API directly to Zebra. This one can be done using the browser, call, or Postman. Users can also make use of Zowe API mediation layer through the API catalog to access this JSON data. And then through the MongoDB, if data has already been stored, users can use command prompt or MongoDB Compass to access this data. And then we have graphical data access. This is mostly through Grafana. And then the recent one by my mentor, he used Viva to actually access this data directly to his phone. So at this point, I would like to show us a simple demo on how Zebra presents this data to user. The first one is the browser. User need to just get, in my own case, I'm running this Zebra local host and my port is 3090. So we have specific endpoints. This endpoint is for RMF monitor 3. In this case, I'm requesting for CPC reports. So let me try to do that again. Yes, this is the updated reports. So this is the Eastern time. I believe it is 10 a.m. now. And then there are other reports too, like usage or proc reports. All this can be done through the browser. This is for RMF monitor 3. There's also RMF monitor 2, RMF monitor 3, sorry, RMF monitor 1, and then the static XML. But for the sake of time, I would just like to move to API mediation layer. As we can see, I'm also running API mediation layer locally on my system. We have already onboarded Zebra to API mediation layer using simple onboarding without any code change. This is Zebra. And then we have the set of APIs. This is from the Swagger definition we have provided. In this case, all I need to do is execute this. This now returns a report. In this case, I'm using one of filters. We have also provided filters. In this case, I'm not requesting for the whole report. I just want to get this CPC HCMSU value, which is 365 in this case. So there are also other APIs that users can test. Like in this case, I will now request for the complete CPC report. This now returns the complete CPC report. Then moving to Grafana. As we can see, I've already built some dashboards. These are simple dashboards that I built using Zebra. There are some procedures that have to be followed, like creating a data source, and then finally creating a panel to get this charts. But all this have been provided in the user documentation, so I'll not be going through it. So I'll now like to move back to the slides. So finally, the progress made. We were able to, Zebra has provide flexibility for users. Users can configure this app to make use of it to their own needs. So for this configuration, the configuration can be done using REST APIs. So we try to secure these REST APIs using Java Web Tokens. Then we have conversion of RMF monitor 3 XML report to JSON. We have conversion of RMF monitor 1 CPC and workload reports to JSON. And then we have importation and conversion of RMF monitor 1 CPU and workload XML static files to JSON. And then we have saving RMF monitor 3 data to MongoDB. And then finally exporting custom metrics to Prometheus. And then finally plotting real-time charts using Grafana. So lessons learned. Actually, as I've mentioned earlier, I'm a medical student, but I've learned a lot through this mentorship when it comes to software development. For the first thing, my proposal was likely garbage, but my mentor was able to sit me down and show me how to write a good project plan, what to look for when writing a project plan. And then he has hosted design thinking sessions where I have learned a lot. And then working as a team, as a medical student, I normally work alone when I want to program because I don't have friends that do that around me. So I normally work alone, but during this mentorship, I learned, okay, when experience is brought into team, great things can be achieved. Like my mentor has 20 years of experience, so that has speed up the development of this app. And then the energy. So when we have to achieve something, we don't care. We spend the time needed to achieve that thing, even if it is during the weekends. We don't normally work in weekends, but when there is need, we put in that energy to work on the weekend. Then like collaboration. When we have issues, we collaborate with other teams like the Zowe API mediation layer to get this thing running on our local host. And then finally tools. I've learned tools like how to use tools like GitHub, Trello, Docker, and Linux. And then finally, the project can be found at this URL. And then finally, I would like to say thank you to OMP for giving me this opportunity. And thank you to my mentor for taking all the time to support me through this journey. Thank you all.
Thank you. Definitely appreciate your presentation and all of your work there, and apologies for the technical difficulties. So we have one more, which I'm going to do real quick here. We have a video from Kai, and I'm going to try to share my screen with that. Let's see if this goes. Oh, if you could stop sharing your screen,
Yeah,
Zowe.
I'm trying to do that. Oh, stop sharing. I said it.
There we go. All right. No worries. No worries. All right. And we're going to try to share the sound here. So we'll see how this goes. Zoom is going to. Oh, this may not work. All right. Let's see if this works here. I'm going to start playing it. And we'll go from there.
Hi everyone, I'm Kai Wang. I am a software engineering junior student from Beijing Institute of Technology, Zhuhai, and an open source lover. I have experience in multi-programming languages like C, Java, Go, JavaScript, Python, and Rust. I love trying new stuff and making fantastic projects. During my freshman year, I was a student participant of Alibaba Summer of Code 2019 and wrote an online GUI designer for iOS things. Now I am a mentee of the Open Mainframe Mentorship Program. I am also maintaining a pool of async written in Go, which is an open source project of Tsinghua University Tuna Association. I am an enthusiast in open source. I think the mentorship provided me a really good chance to learn about awesome open source projects and experience modern and formal development. Without the mentorship, it's impossible to share my idea and code all over the world. Mainframe has transformed over the past 65 years and still is the go-to platform for high transactional and secure computing. Before the mentorship, I didn't know much about mainframe. This mentorship opportunity for Linux Foundation will surely improve my skill about mainframe. What's more, during the COVID-19 pandemic, the mentorship provided me with the opportunity to work remote so I can stay at home. Debian Prometheus exporter is not maintained anymore. FEILONG is an open source Debian cloud connector project. It provides an easy way to manage Debian. It's suitable to improve Debian Prometheus exporter. My project is to write a new Prometheus exporter for Debian matrix based on FEILONG. Now I just released the second version of the exporter. It's available on the Python package index, and you can install Debian FEILONG exporter via the Python package installer. Before the mentorship, I had no clue what a mainframe is or that it even existed. I became a mainframe software development in the mentorship. The most important thing, the code I learned the coding and software architecture skill in the mentorship. Thank you for watching.
Awesome. Thank you, Kai, for that great presentation. And I want to thank all of you watching this. I want to thank all of you mentees. You've done amazing work and made great contributions to the open source ecosystem of Mainframe. Definitely, you can check out more at some of the links that they provided, and they'll also be around the conference here all week. So definitely go reach out, meet them, and connect with them as well. Thank you all, and have a great rest of Open Source Summit Europe.
Thanks, John and Bob.
And we're clear. All right, thank you all very much.